Today, we're going to be going through the Learning Networking Fundamentals path on TryHackMe. And we're actually going to start with the What is Networking room in this video. And that's going to help us understand kind of the basics of networking, some of the methodologies, and just kind of the broad scope, big picture details about networking. So whenever we start to dive into some of the other topics, especially whenever it comes to cybersecurity, it's all making sense. We're going to get started on all of that right now. So here you can see the networking fundamentals path is the second path that you'll have to do. And if you haven't already seen the cybersecurity introduction room, we completed that already. So definitely check out the channel if that is something that you are interested in. But now we're going to be diving into the network fundamentals path. And specifically in this video, we're going to be going through what is networking. And this will give us the fundamental picture on what networking is. So what is networking? Well, it can be found in all walks of life, as they say. The public transportation system, how is it that buses are being tracked by your central command and control node that allows them to be able to track, okay, this bus is on time, this bus is late, this one's ahead of schedule, these drivers are going to be off their shift here in a minute, these ones are coming on a shift, how we get these buses in. It's a giant puzzle, and it all requires networking. Infrastructure such as the national power grid for electricity. Absolutely. Again, and a lot of this kind of stuff, it requires, some sort of command and control. And in order for you to be able to, command and control, you have to have networking with your endpoints. Meeting and greeting your neighbors, pretty basic. And a lot of this is a bit more theoretical. You might even, if you want to say hey to them online, that requires networking. Then postal system for sending letters and parcels. If you have, some method of tracking that online, then it requires some amount of networking from the different facilities that your parcel is passing through. But, and I think it's talking here just about the idea of networking, but, there's actual networks, like computer networks involved in these as well. So it can literally be formed anywhere from 2 devices to billions. And by billions, we're talking about the wider internet. The internet is a network. It's a giant, that's why we call it the net, right? The internet, it's the network. These devices include everything from your laptop, phone, to security cameras, traffic lights. And if you go to Shodan, you can actually see some of these devices that are publicly broadcasted or accessible to the internet. It's kind of freaky. So definitely be careful if you have, security cameras. A kind of a famous and frightening example is a baby cam. Sometimes people don't change the default passwords on their baby cam, and then they don't realize that their baby cam is accessible to the internet. And people find that. So that's very scary. I mean, obviously change the default password, but do try to make sure that it is, not exposed to the internet. You'll have to edit that in your router. So we'll take this diagram and let me go ahead and reset my progress here before we dive in. Spoiler alert. So what's a key term for devices that are connected together? Networking. Beautiful. What is the internet? So we've established kind of what a network is, but the internet is basically the giant network, right? And you're combining different, smaller networks. You can, think of those as a subnet, but smaller networks that let's say an organization has, and then your small home network, and it's networking all of those together so you can all access, different resources. It allows you to basically go to Facebook, or it allows you to VPN for work, stuff like that. So, we have all this text here. I know a lot of you guys were kind of saying, hey, just summarize the text. Basically, that's what we're talking about. We're going through the history of the internet right now. And the first iteration of the internet was the ARPANET in the 1960s with the DoD, the U.S. Department of Defense. But again, it took a little bit longer for it to be an actual internet that we know today, the internet that we know today, invented by Tim Berners-Lee, and that was the creation of the World Wide Web. Here you kind of see what I was mentioning earlier, where you have these different networks that are all networked together in the internet. That's really what the internet is. It's just the giant network that networks other networks. How many times can we say networks on this stream? Not enough. So who invented the internet? Tim Berners-Lee Oh, I spelled it right. So good. Terrible. Unacceptable. Identifying devices on the internet. And I'll view this site here in just a second. To communicate and maintain order, devices must both identify and be identifiable on the network. And so you probably already know about these IP addresses. And these are actually changing a little bit. We're going to talk about that here in just a second. And I will see if I can pull up an example of this. Yeah, because it doesn't talk about IPv6. So we're talking about IP addresses. So there are 4 different octets. Each can go up to, from 0 to 255. There are a few private IP ranges. I wonder if so yeah, this is one of them, is the 192.168. And then you have 2 other octets that you can play with to build out that private network. The 10, I believe it's just 10 go. That should be, where the first octet is 10, I believe that is its own private network. And then 172. So here we have, these are the different IP ranges. So we already talked about 192.168. 10.0.0.0 to whatever, you get those last 3 octets, and then we got 172.116, and then you can do 172.131. That gives you a couple octets to play with as well. A little bit more than that, but you get it. And here, this actually shows you how many IP addresses you can play with each IP address range. The 10, as you can tell, the 10.x gives you way more IP addresses, over 16 million. I mean, almost 17 million IP addresses. And so that's, if you're wanting to build a huge private network, using the 10 IP range is pretty good. So you're probably already familiar with IPv4. That's really what we've been playing with. That's where you have those 4 different octets. However, a problem kind of started to appear where you have a growing proliferation of devices on the internet, but you only have so many IPs that you can really play with, right? And so you need a new method for creating IP addresses to continue to assign to new devices that, basically ups the limit of the amount of devices that you can have on the internet. And so we're going to talk about this picture right over here on the side. This is from Comparitech. So credit to them for this graphic. So here on the right side, you can see IPv4, and you see kind of what that looks like. Again, it looks a lot like what we were talking about, and the range is 4.3 billion possible addresses. Now that might sound like a lot, but there's 7 billion or over 7 billion people on the planet. Does everybody have a device? I mean, that's a great question. I'm not exactly sure, but most of them probably have some kind of a cell phone, some sort of a mobile device, which might require, it probably requires an IP address. Then you have all kinds of other devices that businesses have that need to be public facing. And so that number is really very small. IPv6, on the other hand, and you see the kind of the schema for these addresses, it definitely looks a little funky. And it's using hex or hexadecimal to kind of express the address, but it gives you 340 undecillion possible addresses, and I've literally never heard of that number before. So let me real quick pull up a tab on how many zeros undecillion is. Undecillion has 36 zeros. So that's a lot of IP addresses, right? It gives you, as you can imagine, a much wider flexibility on devices that you can be putting onto the internet. So we're actually, no, I lied. They do have it here. I'm a goof. I didn't even see this graphic. So you do see IPv6 here, talked about here, and they're kind of going through really the backstory of what's going on. So yeah, they talked about it. 340 trillion plus. I mean, unbelievable. A lot of IP space. And you can see this is really like what a full IPv6 address will look like. I mean, as you can imagine, the amount of variance here is 340 trillion plus, right? So that's not the only unique identifier that devices have. They also have a MAC address. and this is what a MAC address looks like. And these can be assigned to actually like the physical device, and these are also expressed in hexadecimal. So you get a lot of obviously uniqueness in these kinds of addresses. So it's split. The first three sections are who built the network interface. And then on the right three, you have the unique address for the network interface. So there is a schema to it. They can be faked or spoofed. Like we already know that IP addresses obviously can be faked or spoofed. MAC addresses can also be faked or spoofed. And this happens, whenever it's basically pretending to use another. I mean, by definition, what spoofing is. So, be careful. What does IP address stand for? Internet Protocol. That's what I thought. Whatever. What each section? Octet. And how many sections and digits do they have? How many sections? 4. Was a MAC media, right? Media access control. Yep. Okay, so let's go ahead and deploy the interactive lab, and let's look through that. Beautiful. So Alice is sending packets through the router to tryhackme.com. Okay, so let's try requesting the site. Bob starts doing the same thing. So Bob's requests are being routed to trash. Why is this? Bob's. Okay, so that must mean that there's some sort of a block on his MAC address. So let's try spoofing Alice's MAC address. 32F 3339. Let's try requesting again, and the requests start going through. So, sometimes you might have some sort of a block going on, and to get by that, if you are spoofing, that might get you past a block. Because again, the router in this case believes that you are Alice. You are not Alice, but the requesting MAC address reflects that of Alice, so it's going to treat you like Alice. That's why it passes it on to tryhackme.com. So ping, and you probably know what ping is, but if you don't, super cool, you're in the right place. It is one of the most fundamental tools available. It literally lets you check if a device is up, like available to the internet and responsive, or if it's down or not responsive. And it'll show you it'll show you how many packets it receives, how many are lost, and how much time it actually takes to respond to that. So what protocol does ping use? ICMP, which ICMP stands for Internet Control Message Protocol. Super easy, super simple. You've probably, again, played with ping, and that's a great way to test if you have connectivity to the internet and you're not sure. Literally ping Google 8.8.8.8, and if it's responding to you, then you are connected to the internet, so good to go. So go ping 10.10.10.10, and then let's go and check the interactive site. It's probably gonna say ping blah, 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 blah. So let's go ping 8.8.8.8, and it's literally, so this is just gonna send I believe 4 packets to 8.8.8.8 to Google. 4, yep, there you go. And it'll return a flag for you. So super easy. Ping is very fundamental. You've probably, if you are further along in your cybersecurity journey, you've definitely played with ping at some point. If you've messed around with networking, you've played with ping before probably. But if you haven't, you're in the right place. That is exactly why we're here. So the next thing we're going to look at is the LAN room. And that is the networking, the what is networking room. So if this was helpful, definitely hit that like button and join in for the next walkthrough.